So we're going to be looking at electronegativity. Essentially, in the product table, you're mainly going to be dealing with the elements that we see right here. You're going to be dealing with the first two on the left side. So we have our hydrogen, lithium, all of our salts. We don't really do with transition metals or metals. And then we have everything on the other block, right? So when two atoms form a bond, we want to make sure that we know how to classify that type of bond that's being formed. So you see here that the electronegativity difference is 0.5, right? So if I were to take 1.0, 1.5, 2.0, 2.5, and so on, what you want to think about is that the difference in, if the difference in electronegativity is less than 0.5, this is saying that the electrons are being shared equally in that bond. And in doing so, there's a very small difference in the electronegativity itself. So let's say, let me get this, let's say we have a carbon with another carbon, and that is a bond. We're going to say that there's a very small difference in electronegativity, so we're going to call that a covalent bond. This is a covalent bond. Now, this also applies for a carbon bonded to a hydrogen. Now, if we were to have, if the difference of electronegativity is between 0.5 and 1.7, the electrons are not shared equally between the two atoms, and this is going to result in a polar covalent bond. And an example of this is nitrogen forming a bond with a hydrogen, a carbon forming a bond with an oxygen, lithium forming a bond with a carbon. So this is not equal sharing. And then lithium forming a bond with a nitrogen. But what I want you to see is, in this case, it would be lithium right here with a nitrogen. So from a 1.0 to a 3.0 is further away than if I was a lithium with a carbon. So this one is more towards, it's a stronger polar covalent bond, in other words. Okay? So if the difference, so let's put these numbers here. So less than 0.5, between 0.5 and 1.7, anything greater than 1.7 is going to be known as ionic bond. And when you think of ionic bonds, the first thing that should come to mind is NaCl. Other words, table salt. All right, so this has a large difference in electronegativity. So the electrons are not going to be shared at all. So if we were to look at this, we have sodium. And then we have our, well, I'm just giving you another example. OH. So this would be NaOH. Right? And so this would be a positive. Then if we have this guy over here, remember we talked about our Lewis dot structures? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, because it's bonded to the hydrogen. 1, 2, 3, 4, 5, 6. It has an extra electron, 7. Negative charge, a negative and a positive charge come together to make NaOH, but the electrons are not going to be shared equally. This is called an ionic bond. Why this is important is that you're going to want to know how to classify partial negatives and partial positives. So if we were to identify the types of bonds based on what we just learned, where would our polar covalent bonds be then? In this structure here. So between carbon and oxygen, that is a polar covalent bond. So it would be right here and right here. So where would our dipoles be pointing in this case? They're going to be pointing towards the most electronegative atom. And here this would be the most electronegative atom. Why? Because this is the value down there. So they're going to point towards the most electronegative atom. So that's the polar covalent bond located there. And if we were to assign the charges, then this would make a partial positive charge characteristic. This would be our negative. And this would also be a partial positive. Because this oxygen, if we were to put a cloud over it, really likes to hoard the electrons. And this is like two small little clouds here and two little small clouds there. So now looking at this particular structure here, I want you to look now and then identify any polar covalent bonds, which we're going to be using our symbols of partial positive and partial negative. And we're going to figure out where they go. So in this case, we have a carbon with an oxygen, as we said before. Where are those electrons going? It's going to go with the oxygen because it's more electronegative. Positive. It's going to go positive because it's going to go to the oxygen. Electronegative. And then this again, positive. So the dipoles kind of go this way, indicated by an arrow. And same here. So they all go towards the most electronegative atom. In this case, which is the most electronegative atom? Well, we know fluorine is located here on a periodic table right here. So that's really electronegative, the most electronegative atom in the periodic table. So that's going to be where the electrons are going to be at, which then leads this guy to have a partial positive characteristic. But some of these electrons from the carbon are going to be pulled towards that chlorine as well. Sure, most of them are going to be hanging around with fluorine, right? Because it's more electronegative. However, they're going to be right here as well, and then very little in the carbon. That makes sense? And this is also going to have negative charge. Now let's look right here. Magnesium is a salt. Salt usually bears positive charge. So then in this case, our carbon is going to have that negative characteristic. Magnesium is going to have a positive. Bromine, where is bromine located? Oh, right here. Very electronegative, 2.8. So then between the magnesium and the bromine, they're going to go to the bromine. Between the magnesium and the carbon, they're going to go to the carbon. And then like that. Based on electronegativity. So then if we look at this structure here, we know that oxygen is going to be more electronegative than carbon and than our hydrogens. So every time you see a carbon-oxygen bond to each other, and oxygen, so carbon, oxygen, where are they? Right here, and right here, right? We know that there's going to be some positives and negative characteristics. Oxygen and hydrogen is another one. That is going to be polar covalent. So if we were to put our partial charges, they're going to be mainly on this guy. We talked about the carbon. This is negative. This is partial positive. this would be partial positive, then they're all gonna go right here to the oxygen, and then this leads this guy partial positive as well. Okay, so let's look at this one. We see a double bond. We talked about carbon and hydrogen. That's a covalent bond, so we don't need to worry about that. We have a carbon, however, with a double bond. So what I want you to see is a double bond with oxygen is more electronegative than carbon. So then the oxygen is going to be more electronegative, more electron rich. So the electrons are going to want to go there. And then the carbon is going to be deficient in electrons, so the electrons are going to be pulled this way. And there's going to be a little bit of electrons here, so it's deficient. That's about it. Everything else is a covalent bond. Alright, so for our next one, we see a carbon surrounded by a bunch of chlorine. We know on the periodic table that chlorine is electronegative. Well, more than carbon. So then all of the chlorines are going to have that partial negative. And what is our carbon going to have? Partial positive. And that is it for electronegativity.